Figures 13.1 through 13.5, assigning addresses of base class and derived class objects to base class and derived class pointers. In this example, we're going to revisit the commission employee base plus commission employee hierarchy, which we defined in the last lesson. And for the purpose of this example, we'll be focused just on main because we're just reusing the existing classes. And basically what we want to be showing you here is how you can take pointers of base class and derived class types, aim them at various base class and derived class objects, and invoke functionality via the pointers. And in this example, we'll be focused on the is-a relationship once again. We'll also talk a little bit about the problems with what we're going to encounter here as a way of helping introduce why polymorphism is important, and a concept called virtual functions is important as well. So let's take a look at main, and here you can see in main that we've created a commission employee object for an employee named Sue Jones. We've also created a pointer of type commission employee called commission employee PTR, and we've initialized it as a null pointer. Remember, the 0 value in C++ means pointer to nothing when you're using it with pointers. We also created a separate employee, Bob Lewis, of type base plus commission employee, and we created a pointer of type base plus commission employee as well, and we'll be using these pointers throughout the code. Now, before we go into assigning objects of base and derived class types to pointers, we want to just output the contents of these two objects so that we can see what's going on in the rest of the program. So here at lines 36 through 39, we display the contents of each of the two objects we created. And if we stop here for a moment, I've already executed the program, and I just want to look at the output with you, where you can see that the employee Sue Jones was output and the employee Bob Lewis was output, and you can see the type of each employee. And then separately you can confirm that these were initialized properly by looking at the values that were passed to the constructors in each case. And we'll be revisiting the output that you see here at the top of the screen as we proceed through the rest of the code in main and look at the rest of these outputs down below. So what we're doing here is using a commission employee object to invoke a print member function, and because we're invoking that member function explicitly on a given object, we know not only the type of the object but explicitly which version of the function is being called as well, and the compiler is able to compile that code and the linker link it together so that that function can be called. And the same thing's happening here at line 39 as well. We know we have a base plus commission employee object for which we were calling the print member function. Now, when you start dealing with base classes and derived classes, it's not uncommon to use pointers of the base class and derived class types to refer to or point at objects of those types. And in fact, it's common to use references as well, which we'll learn more about later in this lesson. So here at line 42, we have a pointer assignment where we're assigning to the variable commission employee PTR the address of the commission employee object. So on the left side of the assignment, we have a commission employee pointer as declared back towards the beginning of main, and on the right side we have the address of a commission employee object, and the address of an object is a pointer to that object. The type of the pointer on the right side of the assignment is pointer to type commission employee because we're taking the address of a commission employee object. So that means on the right side of the assignment we have a value of the same type as the variable on the left side of the assignment, and therefore this assignment is allowed at compile time. Now, once I have a pointer to an object, as we discussed back in a prior lesson, you can use the arrow operator to invoke member functions on that object. So because commission employee pointer points to a commission employee object, we can invoke that commission employee's print member function. And if we stop there and look at the next line, chunk of the output I should say, we can see that Sue Jones, our commission employee, is once again being output, and you see the same values that were output up above being output down here. Now, next we are going at line 48 and aiming a base plus commission employee pointer, that's the derived class type, at the address of a base plus commission employee object. So on the right side we have ampersand base plus commission employee, which gives us a pointer of type base plus commission employee. On the right side we have a pointer of that type as well, so this assignment is allowed. You're always allowed to aim a pointer of a given type at an object of that same type by taking the address of that object, and we're doing that both here on line 42. Here on line 42 and again at line 48 as well. So once we've done this assignment, we now have a pointer aimed at the base plus commission employee object, and at line 52 we're going to invoke the print member function. Now when the compiler looks at a statement like this one or the one back at line 45, it looks at the type of the pointer. Because it knows the type of the pointer from the pointer's declaration, it then knows which class to look in for the print member function. So because this pointer is a pointer of type base plus commission employee, it knows to look for the print function in class base plus commission employee. If you hover over the other pointer back at line 45, you see that it knows inside the IDE here that the pointer is type commission employee star, so it knows that this print function must be in the class commission employee, and if it can't find those functions, it's going to generate compilation errors. Now here's an interesting thing that we get out of the inheritance relationship. Here we have a base class commission employee pointer aimed at a derived class base plus commission employee object. Now remember, based on the inheritance relationship, we can see here at line 12 of the class base plus commission employee that a base plus commission employee is a commission employee. So because a base plus commission employee is a commission employee, we can take the address of a base plus commission employee object and assign it to a commission employee pointer. So a base class pointer can be aimed at objects of the base class and at objects of all of that class's direct and indirect derived classes. And that is what the ISA relationship gives you. And the same is true with references as well. If I have a base class reference, it can refer to a base class object or an object of any direct or indirect derived class. Now, once you have this assignment in place, when the compiler encounters line 59, it doesn't care what the type of the object is that the pointer is pointing to. At compile time, it's going to look at the data type of this pointer. It's then going to go to the class for the data type of the pointer and check to see if there's a print function that takes no arguments. And of course, in class commission employee, there is such a print function. That's number one. Number two, when it binds this print function call to the object that's being pointed to, it's going to use the version that is from class commission employee, even though I know this pointer is aimed at a base plus commission employee object. So if you take a look at the output here, you can see that for the last chunk of the output, we are outputting Bob Lewis, who is our base plus commission employee, but look at the format. It doesn't say base plus commission employee here, and there's no information at the bottom about the base salary. So this is clearly, if you look at the format of the output, the print function from class commission employee being invoked on our base plus commission employee object. So by default in inheritance in C++, when you aim a base class pointer at a derived class object, any member functions that you call through the base class pointer are going to be the base class versions. And there is a way to make it call the derived class versions, which is this concept called polymorphism that we'll be studying in more detail over the next several videos. First, we're going to talk a little bit more about aiming base class pointers and derived class pointers at base and derived class objects. Then we'll take a look at the polymorphism concept in detail. So what we're seeing here is that via the ISA relationship, you can assign a derived class objects, a pointer to a derived class object to a base class pointer variable. And the compiler, as long as you're going up the hierarchy as you proceed from the right side to the left side of the assignment, the compiler will allow these assignments. So when I say up the hierarchy, remember when you define a diagram of a class hierarchy, you start with the base class at the top and the derived classes at the bottom. As long as the type of the object on the right side is a derived type of the type on the left side, then the assignment is going to be allowed because we're going up the hierarchy as we go right to left across the assignment. So now that we've started to talk about this is a relationship in a little bit more detail, we're now going to take a look at a couple of examples that show you various compilation errors so that you understand what you can and cannot do with base class pointers, and then we're going to take a look at the concepts of polymorphism in detail.